Okay folks, so welcome to today's video, which is on qualitative chemistry, which is basically kind of like forensic science really, is the tests you need to do to identify certain unknown substances. So the subtitle for this one, today we're looking at ion tests for negative ions. So there will be a upcoming video where we do the tests for positive ions. And also in the video today is a test for ammonia. And ammonia isn't technically a negative ion, but to make the split of the video nicer between the negative ones and the positive ones, I've included ammonia here. Okay, as always, quick quiz. So if you want to pause the video and have a go at these questions, so I'll restart the video in around about 5 seconds to give you time to pause it, actually have a go at these questions. These are information that you are going to need to know today. I suggest you go and watch the video I've done on solubility rules if you haven't yet, because the solubility rules lesson is a bit of a prerequisite to this one. Okay, so I'm going to go through these answers now. So all chloride salts are soluble except for all chloride salts are soluble except for silver. So silver chloride and lead chloride. So iron chloride, copper chloride, sodium chloride, they are all soluble. The only ones that are insoluble are silver chloride and lead chloride. Those are the exceptions. So all sulfate salts are soluble except for lead sulfate, sorry, I've got a really bad headache today, so I'm going to try and power through by being like kids TV presenter, full of enthusiasm. So lead sulfate, barium sulfate, and calcium sulfate. So the chlorides all soluble except for silver and lead. The sulfates are all soluble except for lead, barium sulfate, and can't really fit it in, calcium sulfate. All carbonate salts are insoluble. I'll do this one down here. All carbonate salts are insoluble except for sodium carbonate, potassium carbonate, and ammonium carbonate. And if you remember, those are the three exceptions to all of them. All sodium salts are soluble, all potassium salts are soluble, all ammonium salts are soluble. So all the carbonate ones are insoluble except for those three. Right, what is the formula of a carbonate ion? So a carbonate ion is a complex ion. It is CO3 2-. So that is one negative ion. It is made of 4 atoms. It's one negative ion. So if you had, let's say, sodium carbonate, so sodium's in group 1, it loses 1 electron, so it makes Na+, CO3 2-, so you're going to need 2 of these. So you would have Na2CO3. That's how that would work. So a carbonate ion is CO3. And then how does this work? So back revision from the acids topic, acid plus metal carbonate, you make your salt. And the salt, member, part of it comes from the metal and part of it comes from the acid. So you make your salt and water. And then also, because there's a carbonate there, you are going to make carbon dioxide. I will just give you an example of that. So if the acid was hydrochloric acid, so let's say hydrochloric acid plus calcium carbonate. So the salt is going to be calcium chloride. So we make calcium chloride plus water plus carbon dioxide. Okay, so that's the quick quiz for today. So ion tests for negative ions, how do these work? So essentially, the idea is you get given a test tube of an unknown substance and you need to identify it. So I'm just going to draw 3 test tubes here. Right. So we've got test tube A, test tube B, test tube C, and I'm going to say that, let's make it easy so we know. One of them is magnesium chloride, one of them is magnesium sulfate, and one of them is water. And we need to identify those. So the lesson today is about the tests for negative ions. So there'll be another one which lets us test for positive ions. Actually, maybe instead of water, if I make one of them copper sulfate. So they've all got, magnesium is a positive ion. Remember, metals are losers, so they lose electrons and they become positive. So the magnesium would be a positive ion, the magnesium positive ion, the copper is a positive ion. We're not interested in those today. We're going to identify which are the chlorides and which are the sulfates, because these are the negative parts of it. So the tests that I'm going to walk you through today, we're going to test for carbonate ions, which are CO3 2-. We are going to test for sulfate ions, which are SO4 2-. Carbonate, sulfate. We are going to test for halide ions. So halide as in the halogens. So there's a test for chlorine, bromine, and iodide ions. So this is the same test actually. It gives you a slightly different colour for each of these. But so there are 1, 2, 3 tests, and then this one's got slightly different results. So let's do the carbonate test first of all. And this is where I'll bring in the really important point. The tests for ions must be unique. So why do they have to be unique? That's because if we're going to identify them, if we're going to use a test to identify an ion, it needs to be a test that only gives that result for that particular ion. If we go back to a test we already know, so you should know that the test for carbon dioxide is you bubble it through lime water and it goes cloudy or milky, right? A common mistake on the exam is you get a test tube of your gas, whatever, you know, you got a test tube of your mystery gas. Let's say if you want to test it's carbon dioxide, and they say put a lit splint into the test tube, and if it goes out, it's carbon dioxide. But that's not unique, because there are lots and lots of gases where if you put a lit splint inside a test tube of them, it would go out. Like if you had any of the noble gases, helium, neon, argon, like they would all extinguish a lit splint. So you can't say carbon dioxide will extinguish a lit splint. It's not a unique test. Whereas bubble it through lime water and it goes milky, that only happens with carbon dioxide. So that test is unique. So why must a test be unique? Because if we're identifying an ion with a test, we need to make sure it only gives that result for that specific ion. Right, so I've got some practical stuff set up now, which I'm going to try and film, so hopefully it will come out quite clearly. The first test I'm going to look at is, where are we? Not that one. Where are we? Right, we'll do sulfate ions first of all. SO4 2-. So to test for sulfate ions, if we go back to our quick quiz, and it would be useful if you had a copy of the solubility rules from your notes to hand. If we look, all sulfate salts are soluble except, so these are the ones we can use for our test. So the sulfate salts are all soluble except lead sulfate or barium sulfate. So what we can do is we add a lead compound to our unknown substance. If there was sulfate in our unknown substance, it will make lead sulfate, which is insoluble. But that's not a great test because it's not unique. Because if we look here, chloride salts, lead chloride is also insoluble. So if we've got 2 beakers, we don't know what's in them, right? Oh no, mystery substances. We want to try and identify which one's which. Let's say this one's got some chloride ions in it and this one's got some sulfate ions in it. If we add a lead compound to these, well, lead chloride's insoluble, so you'll get a precipitate appear. But lead sulfate is also insoluble, so you get a precipitate appear. So it's not unique, doesn't solve our problem. So if we look here, so sulfate salts are soluble. We can't use lead because it appears multiple times, so we use barium. Okay, so for our test for sulfates, we use barium chloride, and we need to acidify it, so we use hydrochloric acid. We need to be careful what acid we're using. The reason we're using hydrochloric acid is because this is barium chloride. So hydrochloric acid has chloride ions in it, barium chloride has chloride ions in it, so we're not contaminating our experiment at all. So the test for sulfate ions is barium chloride and hydrochloric acid. And now if there are any sulfate ions there, I'll just write it as sulfate. Are there any sulfate ions? So we add these things. If there are any sulfate ions in our solution, then we will form barium sulfate. And barium sulfate is insoluble, so it will appear as a white precipitate. So if we see a white precipitate, we know the white precipitate must be barium sulfate, which means there must have been sulfate ions at the start. This is where I'm hoping my camera stand holds up. Where are we? This isn't going to work, is it? Come on, don't let me down. Right. Let's add a background so you can see. Let's try and improvise this a little bit more. I'll take this out with the magic of editing. Okay. Right. So our unknown mystery compound. So unknown mystery compound. Pour it in. Right. What I will do actually, I'll get 2 unknown mystery compounds. Ignore that was a tap running. This mystery compound definitely isn't water. Right. Okay, so now, what do we say for our test? So to test for sulfate, we need to add barium chloride and hydrochloric acid. So I'll put a few drops of hydrochloric acid in. Okay, and then I'll add some barium chloride to it. Okay, so mystery compound here, no precipitate appeared, so definitely didn't contain any sulfate. It was water, spoilers. Mystery compound here, we've definitely got a white precipitate appeared, a white solid. So, because we made something insoluble. What have we made? Well, the only possible precipitate we could have made, we added barium chloride and hydrochloric acid. The only barium compound that forms a precipitate is barium sulfate. So that meant there must have been sulfate in that compound. it was magnesium sulfate, so there definitely was. Right. Next test is the test for sulfate ions. Sorry, the test for carbonate ions. And you kind of already know a lot of this one. So carbonate ions, and I don't want to go through the hassle of moving my thing again. So, right, carbonate ions are CO3, 2 minus. So the test for this is we add any acid at all. So any acid. And this is why I made this a question on the quiz, right? What happens if you add any acid to a carbonate compound? And so if I get the quiz question back, if we add an acid to something that's got a carbonate in it, we make salt, we make water, but this is the important one, we make carbon dioxide. And you already know the test for carbon dioxide, because the test for carbon dioxide is to bubble it through lime water. So I'm going to get my test tube, put it there. I'm going to put my mystery carbonate, well, sorry, not carbonate, mystery substance that I want to find out if it's a carbonate. Like, spoilers. It is a carbonate. So, oh no, this is an unknown. Has it got carbonate ions in it? Stay tuned to find out. So imagine that, instead of knowing that that's sodium carbonate, imagine that is a mystery substance. So we're going to add any acid, which is going to produce carbon dioxide gas. And then the test for carbon dioxide is to bubble it through lime water. So I get my test tube. I get some lime water. I'm going to chuck some lime water in there. Put that one there. So that is lime water. And I'll leave that there just so you can see. And the idea is I stick a tube in the bottom of that one. I stick a bung in the top. And then when I need to add the acid first, right? But if I add the acid, the only gas that could be evolved from me adding an acid is if that's a carbonate, and then the gas would be carbon dioxide, and then to check it's carbon dioxide, I'm bubbling it through lime water. So it doesn't matter what acid you use for this one, anyone will do. So I've got some hydrochloric acid here, so I'll chuck in the hydrochloric acid, put the test tube on the top, put the bung on the top, and then hopefully, although I might have missed it, might not have added enough. We should be getting some bubbles through there. Maybe I'll add some more. Yeah, and I don't think I've added. There we go. Still not quite enough to go cloudy. Right. Okay, failure. Maybe it's too much the other way. This is enthralling, right? It's still not enough. Brilliant. Means I've got to add some more of the other one. Shouldn't have added so much lime water. Okay, right. Imagine that's gone cloudy. Woo. Okay. And that's the test for carbonate. So it's actually the test for carbon dioxide. So you add an acid. If you get a gas, it must be carbon dioxide. Sorry, add an acid, get a gas, test the gas. If the gas is carbon dioxide, we must have started off with a carbonate. Okay, let's move this out of the way. Right. We're going to look at halide tests now. So, halide tests. And from our quick quiz, where we look at question 1, all chloride salts are soluble except for silver and lead. But we can't use lead because of reasons we talked about earlier, because lead would also give us a precipitate if it was sulfate. So we're going to use silver, right? We're going to... Okay, so this is Mr. Tinkler from the future. My video messed up, stopped recording, and I didn't notice. So here's me adding in over the still edit, so show you what you forgot. The first compound has a chloride compound in it. The second one is potassium chloride. The second one has potassium bromide, and the third one has potassium iodide. And what you've missed out on is I have added silver nitrate and nitric acid to them both. So when I add silver nitrate and nitric acid to the first one, it makes silver chloride, which is insoluble in a white precipitate. When I add silver nitrate and nitric acid to the second one, it makes silver bromide, which is a cream precipitate. And then that's where this video picks up. So it's the difference between chloride gives a white precipitate, bromide gives a cream precipitate, and then iodide you'll have to watch. Okay, splitting that video. I'm not sure it's as obvious to you, but there's definitely a difference there, right? One of them's cream, one of them is white. And then silver iodide. So I'm going to add silver nitrate, nitric acid, and if there's iodide there, it forms a yellow precipitate. That's the example colours you need to know, right? White, cream, yellow. So it means as you go down the periodic table, so you've got chloride's the top one, underneath chloride is bromide, and underneath bromide is iodide. So it gets whiter, white, cream, yellow as you go down. But it's the same tests for all of them. So that is your test for carbonate, sulfate, and halide ions. There is one more, but I'm going to try and rearrange my camera so that I can write a bit more. Okay, let's try that. So, to recap, thanks for sticking with this. Right, so to recap, how can we test for carbonate ions? So we add any acid. If there's carbonate, it will give off a gas, and that gas would be carbon dioxide, and then we bubble it through lime water, and if it goes cloudy, the gas was carbon dioxide, which means we must have started with a carbonate. How do we test for sulfate ions? Well, we add barium chloride and hydrochloric acid, and then if there is sulfate there, we would make barium sulfate, which is a white precipitate, and then halide ions, so chloride, bromide, iodide ions. So test for all those is the same. We add silver nitrate, and nitrate means nitric acid, right? Chloride, hydrochloric acid. Nitrate is nitric acid. And then you would make silver chloride or silver bromide or silver iodide. And silver chloride is a white precipitate, silver bromide is a cream precipitate, and silver iodide is a yellow precipitate. Right, final test for today is the test for ammonia. And ammonia is NH3. Do not confuse it with ammonium. Ammonium is NH4+. That's not what we're talking about today. We're talking about ammonia, which is NH3. And the test for that is... So we've got ammonium hydroxide. I'm going to add some sodium hydroxide to it, which is going to make ammonia as a gas. It's not going to smell particularly nice. And then I'm going to get some, it's important you get these colours right. I'm going to get some damp red litmus paper, and it's going to be a colour change. So I've got my damp red litmus paper. I've got my mystery solution that I want to see if it contains any ammonia. So I'm going to add some sodium hydroxide to it. And then hold that over the top. And hopefully you can see that it's going blue. So the test for ammonia is to add sodium hydroxide and get damp red litmus paper, and it will go blue.